Have you ever wondered how Roblox turns simple 3D models in the games we play into 2D images on a screen? It's all thanks to a process called rendering that is behind every shadow, texture, and light effect you see in games in the platform. Roblox Studio uses the same core techniques as giant engines like Unreal Engine and Unity, just in a more accessible way. I will show you how video game graphics work in Roblox, and with this we'll understand a little bit how all games work behind the scenes. The rendering pipeline is the sequence of steps that transform 3D objects into a final 2D image displayed on the screen. Roblox follows a simplified version of this pipeline, optimized for real-time rendering on a variety of devices, like PCs, consoles, and mobile phones. The rendering pipeline in Roblox consists of three major steps: Vertex processing, Rasterization, and Fragment processing. I will explain each one of these steps so we can understand how Roblox games graphics work. But before we dive in, let me explain some fundamental concepts to make everything easier to understand. In a 3D model, we have three key components: vertices, edges, and faces. Vertices are points in a 3D space. They have X, Y, and Z coordinates that determine their position. For example, a cube has 8 vertices, one at each corner. You can think of vertices as the dots that define the shape. An edge is a straight line that connects two vertices. A cube has 12 edges. If vertices are the dots, edges are the lines that connect them. And finally, a face is a flat surface enclosed by multiple edges. A cube has 6 faces, one for each side. Each face is made up of 4 edges and 4 vertices, at least for the cube. And after learning these concepts, there's just one more thing that we need to understand. It's that geometry is the structure of a 3D model, made up of vertices, edges, and faces. It defines the shape of the model. When you import a 3D model into a game engine like Roblox Studio, the geometry, vertices, edges, and faces remains the same, but the engine automatically converts everything into triangles, also called trees, for rendering. Here's an example of a 3D model that I made up in Blender, a 3D software, and the comparison of the change of geometry when I import into Roblox Studio. As we see, everything is made up using triangles. But why? Triangles are simple, just 3 dots, and always flat, making them easy for computers to process. And everything can be built using triangles, no matter how complex the shape is. And after all this introduction, let's finally start with the first step of the rendering pipeline. The first step in rendering a 3D scene is vertex processing, which involves transforming 3D objects so they can be displayed on a 2D screen. This process takes all the object's geometries in a 3D space and uses the camera's field of view to determine where each object should appear on a 2D view screen, the final image sent to the display. In a Roblox map, there can be thousands of parts, meshes, and other stuff. However, the camera's field of view sections off only what the player actually sees. For example, if a map has 10,000 elements, the game engine will optimize rendering by reducing the number of objects that need to be processed at any given time. Let's take Emperor, a stand from Just This Adventure, as an example. What we see as a single 3D object is actually built from hundreds of triangles, connected through vertices with one texture applied to its surface. Conceptually, Emperor is moved as a whole onto the view screen, but in reality, each of its hundreds of vertices is individually processed and transformed. To understand this process better, let's focus on a single vertex. Moving a vertex, and by extension an entire object, from a 3D workspace to a 2D view screen is done through a series of transformations. These transformations happen in 3 steps: model space to workspace. When you create a 3D object in Blender, all the vertices have positions based on the object's own center. For example, if you have a cube, its vertices might look like this. These numbers only make sense inside of the cube itself. They are relative to its own center. This is called model space because the position of vertices depends only on the object, not the outside world. When you bring the cube, and therefore the vertex, into Roblox Studio, it now has a position inside the game's world. Instead of just existing in its own place, it's placed somewhere. If you move the cube in Roblox Studio, that means its entire object is not a position in the world. The cube's vertices also move with it, but their positions relative to the cube stays the same. Now, the cube's location isn't just based on itself, it's based on where's in the world. This is called workspace. Workspace to camera space. Next, the game adjusts the cube's position based on where the camera is. This step decides how the object should look from the player's perspective. Camera space to view screen. Finally, The vertex is projected onto a 2D view screen so it can be displayed on your monitor. Think of it like looking through a camera lens. While the world exists in 3D, what you see is a flat image. The game engine uses perspective projection to decide where each vertex should appear on the screen, factoring in the camera's field of view and the object's position. All of this happens in a fraction of a second. After 3 vertices of Emperor are transformed using this process, we get a single triangle moving to the view screen. Imagine all this process applied on a singular 3D model. And now imagine that process being applied to an entire map. Rasterization. In Roblox Studio, rasterization is the process of converting 3D objects into 2D pixels that appear in the screen. The game engine takes all the triangles from the 3D model and determines which pixels they cover on the display. How does rasterization work in Roblox? Converting triangles into pixels. Using the x and y coordinates from the previous transformation step, the GPU calculates where each triangle lands on the screen. It figures out which pixels are inside each triangle and need to be colored. Shading the pixels. Each pixel inside a triangle is shaded based on the object's material, texture, and light settings in Roblox Studio. This is how surfaces get their colors, reflections, and textures. And finally, rendering thousands of triangles. A Roblox scene can have thousands of triangles being processed in real time. The engine continuously shades the correct pixels for every single triangle that appears on the camera's field of view. This is a simplified version of the process. There is still a lot more to cover, like how the Z buffer works to handle depth. But to keep things clear and straightforward, I'll leave it at that for now. This entire process happens every frame, meaning that in a game running at 60 FPS, Roblox has to do this for thousands of triangles 60 times per second. And before I continue with the last step of the rendering pipeline, that is fragment processing, I just want to let you know that if you're interested in the development of my JoJo game, My Golden Heaven, feel free to join to the Discord server. Now let's continue with the video. Testing with the Z buffer. Not all fragments should appear on the screen. Some might be behind other objects. The Z buffer compares depth values and discards fragments that are blocked by closer objects. This prevents hidden objects from being drawn on top of visible ones. Effects: transparency, reflections, and shadows. If an object is transparent, fragment processing determines how it blends with the background. Shadows and reflections are calculated based on lighting conditions, and Roblox screen space effects, like reflections on glass or water, are finalized here. And finally, after passing all these steps, the processed fragments become actual pixels on your screen. This process happens for every frame. Fragment processing is the reason materials look realistic, shadow exists, and objects don't overlap incorrectly. It's the final step before an image reaches your monitor, and it all happens in milliseconds. It's crazy how much happens behind the scenes just to display a single frame. I hope you enjoyed this breakdown of how Roblox renders 3D graphics. If you found this interesting, make sure to subscribe. And if you are interested in the development of my JoJo game, My Golden Heaven, the link to the Discord server will be in the description.